We want to sketch the graph of the conic section given by this equation. So here's this equation here. So as I said, within 3 seconds I should be able to tell what this is. And I look at my A and B values. My A is 4, my B is 5. They're both here, so it's not a parabola. They're not equal, so it's not a circle. They are both positive though. So this thing is an ellipse. It took me longer than 3 seconds, but I was talking. So I knew what it was before I started talking. So um, now I know what format I'm going to be going with. So I'm going to try to. So what I'm going to be doing is doing some completing the square. Now again, as I go through this, I'm going to have to complete the square for my x's and my y's, in the same felt swoop. And here's what that means. Okay, for me to complete the square, I have to get something that has something in the form of a perfect square trinomial. Now, a perfect square trinomial has a leading coefficient of 1. The problem is, I'm not going to be able to get a 1 in front of my x squared and a 1 in front of my y squared at the same time without treating them separate from each other. Okay? So what I'm going to do in this kind of instance, and the reason why I moved the 61 to the other side, is I'm going to kind of group my x's together, and I'm going to kind of group my y's together. And as you notice, I am factoring out the 4 from my x's, and I am factoring out the 5 from my y's. Notice I am factoring out of both terms. A lot of students forget to factor out of what's going to become your middle term when you have your perfect square trinomial, and therefore end up getting really huge numbers for the coordinates of their center of the ellipse, and therefore they have to go really far away from the axis to find them. Now that I have a leading coefficient of 1 inside the parentheses, I can complete the squares inside the parentheses. So again, to complete the squares for the x's, I'm going to take half my middle term, so half of negative 2 is going to be minus 1, and I'm going to square that and get a positive 1. I did just add something to the left-hand side of this equation. I added 1 inside of a parenthesis to the left, which is ultimately being multiplied by 4. So by adding that 1 inside the parenthesis, I actually added 4 to the left, so I'm going to have to add 4 to the right. And in a very similar vein, I'm going to take half of what's going to be my middle y value, which is going to be a plus 3. I square that and get a plus 9. Now I added 9 inside the parenthesis on the left-hand side, but that whole parenthesis is being multiplied by 5. So when I added that 9, I actually added 45. So I got to add 45 to this side as well. Now that I have two perfect square trinomials written inside these parentheses, what I can now do is write them as binomial squared. So the reason why I always write what's that half that middle term is going to be, that is the number that's going to go next to my x or y in the parentheses. So I'm going to have 4 times x minus 1 squared plus 5 times y plus 3 squared. And of course 61 plus 4 plus 45 is 110. I'm starting to see some of the structure of the equation of an ellipse here because I said these parentheses being squared. But I had to also think, okay, well, what do I need to do next? I want to get it into that format. And that format has no numbers next to the parenthesis, being multiplied to it. I do have a fraction bar and a number underneath, which indicates a division of a number. And I also usually just have a 1 on the right. Right now I have a 110. So I got to think, well, what can I do to get me closer to that structure? Well, dividing by 110 can do that. That's going to make the right-hand side 1. It's going to introduce those fraction bars, and I could do some cancellation, okay? When I do the cancellation, I mean, the 5 and the 110, 5 is a factor of 110, so if I reduce that, I do get a 22 in the denominator, 1 on top. 4 and 110 aren't, but I do want to have a 1 in front of that parenthesis on top, so, I just basically, divide the top and bottom by 4 to get the 27.5 on the bottom. That is standard form. It's okay that I don't have perfect squares. They don't have to always be perfect squares for the bottoms of these. Okay? Everyone thinks that, well, if I have a squared and b squared, they have to be perfect squares. They're not. They don't have to be. What this does give me now is enough information to draw a picture, because now I can say that the center is at 1, negative 3. I can say that the value of a is about 5.24. That's a horizontal movement. And that b is the square root of 22, or about 4.69. And b is a vertical movement from the center. It's a vertical distance from the center. So when I plot these, my center is going to be at 1, -3. I'm going to move right 5.24 and left 5.24 from the center and put those 2 points in. I'm going to move 4.69 up and 4.69 down from the center to put those 2 points in as my co-vertices, and I'm just going to connect that with as rounded of a picture as possible. I will at times ask you to draw a graph of one of these conic sections on a quiz or a test or what have you. Please keep in mind, I don't expect it to be perfect. You see my ellipse here is not perfect. I try to make them a lot better when I do it on paper, but on the computer screen, it has limitations as far as what it lets me do very accurately. Yeah, but just make it look elliptical. Do not draw a diamond. I'll have students that'll find those dots, they'll find those points, and they'll give me an answer that looks like this. Say, here's my ellipse. Well, that's not an ellipse. That's a diamond. At least make it look elliptical. Make it rounded a little bit. Don't draw a diamond and say that's my ellipse. Well, no, you drew a diamond. So, and you'll probably lose a point if you do that. And I'll say no, this is a diamond. So okay, this one here. We want to sketch a graph of this conic section. So again, within 3 seconds, I should be able to identify what this is, and that's really easy. I don't see a y squared term, which means that my b value is 0. This is a parabola. And since it's a parabola and the x is being squared, I know I'm going to be using the one that has the format of y being alone on the left-hand side, equaling a times x minus h squared plus k. That's the format I'm going to be using. I'm going to try to get that into this format, though. So what I'm going to do is, okay, I'm going to start isolating y. Okay. So, in this one here, I don't necessarily, I mean, if you want to, you don't necessarily have to put this into the factored or vertex form because of the standard form, because you do have other ways of finding things that are necessary to draw a parabola. Okay, and we've done that with the quadratics already. We've talked about how you could draw a parabola with that earlier in this video. But for this, I'm going to go through that completing the square procedure just because it's a procedure that students probably need to see a few times because they may not remember it a whole lot. So again, on the right-hand side, I'm going to complete the square so I can write that as a quantity squared. Again, my leading coefficient has to be a positive 1, so I'm going to have to factor out that negative first. From both terms that have x in it. So there was a change of sign next to the 6x as well. I'm going to complete the square on the right, so I'm going to take half and square it and get that 9. I added 9 to the right-hand side, but that whole quantity is being multiplied by -1, so when I added 9 to the right, I actually subtracted 9. When I added 9 inside the parentheses, I actually subtracted 9 from the right, so I'm going to subtract 9 from the left to keep it equal. So I'm going to have y minus 4 equals negative x minus 3 squared. Because I completed the square, I can write it as a binomial squared. And I'm going to add 4 to both sides to get y alone. And so I have y equals negative, there's a 1 there, we don't write it, but x minus 3 squared plus 4. So with this format here, I know the vertex is at 3, 4. I know it opens down. And I pick some points, and I pick points over to the right of x being 3. So these are other points that are going to be on my parabola. So again, when I plot it, I find the vertex. I plot those 3 points as well along with it. I also recognize there is an axis of symmetry that goes right here. I'm going to also draw the mirror images of those points, and my parabola will go through all those points. And there's my parabola.